thanks everybody. I'd also like to start out with just a thanks to ZyQuest for having the insight and the courage to put something like this together here in Green Bay. By the turnout, I can see and believe it's much needed and important for us. Also, the diversity of the industries that are talking here today. We've had the techs, Baytech, games. We've talked about jewelry. Now I'm going to talk about environment and environmental cleanups. And I think the diversity is important because sometimes it's when you link thoughts and ideas from different industries is when the innovation really occurs. So we'll spend some time talking about environmental cleanups. And cleanups meaning someplace in the environment, in our water environment, soil environment, where we have chemical contamination that needs to be removed. Next slide, please. So just Foth, we are a service company. There's about 700 of us, 20-some offices. Our home office is here in Green Bay. And we work primarily for industry and municipalities. So environmental cleanup projects, let me just walk through it at a high level. They need data. They need a lot of data. We're looking at over here, this is a site on the Fox River, Little Lake Butamore, the upper portion of the Fox. It needs a lot of data. And the data needs for these projects take years to collect that data. It doesn't happen right away. The bigger the project, the bigger the data needs. This site here is in Ashland, Wisconsin. It's a Superfund site, pretty big project. And that data needs, it'll be millions of dollars of collecting data in order to help solve the environmental cleanup issue and the problem at the site. So data leads to the problem solving. Somebody identifies a site, needs a cleanup, it's got some contamination. We have to have the data to do the problem solving. All right, so I'll give you one example of a key environmental problem, and that's water. And water problems are everywhere right now. So 3 areas where we see water issues. One is the water is impaired. So there's something in the water. It could be a contaminant, it could be a solid, it could be algae. We always see this. There's something in the water that's impaired and needs to be cleaned up. Secondly, it's contaminated sediment or mud. So when you look at a lake or a river, the bottom area, that mud, that is a storage or a reservoir for decades of those contaminants. So that affects the water quality. And then lastly, the fish. Now, people want to always know, can I eat the fish? In many, many rivers across the country, the estimate is about half of the rivers in our country, the fish are impaired. So these are the water quality projects and types of problems that we see. So the problem stakeholders, who cares about this? Well, you've got the clients, the industries. They care. They've got cost, liability, and their brand. The public agencies have responsibilities. US EPA, Corps of Engineers, Wisconsin DNRs of the world. They care about the issues. The public, general public, very much cares. And then it's the engineering and science teams and the construction teams. So that's just a snapshot of who are these stakeholders that are trying to solve these problems. Thank you. Next one. All right, so let's just talk a little bit about the types of data. All right, so often it can be millions of dollars of collection of data that can go on for years. So just the types of data, it's location. You know, where in the river specifically. And sometimes that can be, we need to know the location within hundreds of feet and sometimes within a couple of inches. So location data, the chemical data, the geotechnical data, the soil stability, the geotechnical data. Species, we talked about the fish. There's also the humans, there's the birds. So that's data collection. Hydrological, just think of the waves and water temperatures. So that's more data that we need. Sensors, there's a big push right now for real-time sensors. That we can put real-time sensors out there in the environment and collect that data in a real-time way. And then lastly, construction support. So those are the types of data. All right, the problem solving on it, it's like a lot of problem solving. Somebody identifies a problem, we've got to collect the data, then we have to store and share that data with those stakeholders. And that's difficult at times because the ability in different companies to store and share data differs. And then we have to transform the data. And this is where the magic happens. All right, so you've got this problem, you spent this money, it's taken a lot of years, but the data in of itself isn't going to help you solve the problem. You need to transform that data, transform it to understand the problem. And that's where our need is. I'll talk about that in some specificity, is transforming that data so people can better understand the problem. And then we have to share the solutions, and finally there's action after all of that happens. All right, so let me just give you one example, kind of talk through this problem and to share the need. So the one example, I'll go to the Fox River, because it's right over here in our backyard. And this is in the Neenah, Menasha area. And we had fish advisories, contaminated sediment. So this part of the Fox River has already undergone a cleanup. I'll talk about that story a little bit and then get to the need. All right, so the EPA comes out and they say in this part of the river, and this stretch is about 7 miles long, it's all dredge. All that sediment, all that mud's got to come out. It's going to cost you $150 million. All right, so that's the starting point for this. And then what the team does, what our team did, and the team was a number of companies collaborating. What the team did is we did perform the cleanup, but for $100 million. So significantly less. And if we show this slide here, when they start with an all dredge cleanup, and you look at that magenta color, we ended up with an optimized cleanup. The river is not the same in every location over 7 miles, so the data, transforming it, sharing it, dictated an optimized cleanup, a better cleanup. That's good news. All right, so just a snippet of the data transformation. So when you look over here, you're seeing one location there, there's that little red area. Well, that was the hot spot. That's of that larger river stretch. There were some areas that differed. They were more contaminated, and we had to really focus in those areas. Now, it takes millions of dollars worth of data and transforming that data and sharing it to get to that point. Okay, before the team shows up, this is the upstream part of the Fox River, only 4% of the fish were acceptable for human consumption. That's before. And today where we are, this is the early post-cleanup data, now 89% of the fish show that they're acceptable. Okay? So that's good news, right? Well, so here's the problem, and here's the need. The need is there's a lot of muscling with this data to get to this point. You know, like the term is data wrangling. There's too much data wrangling, too much muscling and data wrangling to get to this point. We need to get here more efficiently. And I had mentioned earlier about half the rivers in the U.S. have some sort of contamination. The need is high. It goes well beyond the Fox River. The Fox River was just an early project that had a lot more focus. All right, the data usage, this has got 2 techie slides, but there's the design platforms, CAD, GIS, spreadsheets, statistical. We need efficient integration of these platforms. That's a big need. The second slide, the data file platforms, text files, the data transfer to those stakeholders. Not only do we need efficient transformation of that data, we need effective communication. All right, again, there's too much wrestling going on. It's too difficult to do. We've got to speed up this process. All right, so I hope I've shown where good data usage has high value. It has high value with the stakeholders, whether that's industry, the public, the government agencies, the stakeholders have a high need for good data usage that leads to high value. So here's our reverse pitch, okay? So we'll be out and back. I'm here with a couple of colleagues. We'll be out and back afterwards, but we're open to ideas on how to more efficiently transform the data, and I would also would say effectively communicate. That's a part of it as well. So how we can transform this data and effectively communicate the data to give us less muscling, less data wrangling, and to move the process along better. So that was my chemistry and environmental lesson for the day. I hope that made some sense to you. Thank you very much.